In this presentation, we are going to look at integration, and in particular, we're going to use trigonometric identities when solving our integration problem. So here is the problem we have. We have the product of two trigonometric terms, cos 4x and cos 2x, and we have to integrate the product of those two terms. So the approach we're going to take here is to use a trigonometric identity from trigonometry. So this is the one that will come in most obvious, as the most obviously useful. So 2 times cos A cos B is equal to cos A plus B plus cos A minus B. Okay, so we're going to use that. How does that work for us? Well, cos of 4x cos 2x, that is equal to cos 6x plus cos 2x. Now remember this 2 over here, so we have to account for that. So what we're going to do is divide this side by 2. We'll actually just divide both of those by 2. So we can rearrange our expression in that form there. So there I have done it again. So it's a half of cos x. I've put the half outside the bracket there. But anyway, so that is what we're going to use. So we're going to rewrite our integration expression in that form there. So this is our original expression up here. And what I've done here is I've used that identity previously that I just mentioned on the last slide. And so I've, as well as the 1/2, I've just substituted in cos 6x plus cos 2x and accounted for the half outside the integration. So what I'm going to do is just separate the two terms here. So I'm going to have this part here and make one expression out of it here. And this part here, including the 1/2, I'm going to bring it down here. So now we have turned the problem into two very simple, straightforward integration problems. These are very elementary integration problems. So we're sort of have the back, we have the main part of the job done. So now all that remains to do is this calculation here. So let's integrate cos of 6x. That is sine 6x all over 6. Bringing in the half there, it's 1/2 times that. And then we have the limits of integration there. Okay, so I'm just going to change that to 12. So I'm just going to put 12 down there instead. So that's 1/2 times 1/6. And we're going to do the same thing over here. What is the integral of cos 2x? So, well, that's sine 2x all over 2. And we have, again, we have the half. And we have the limits of integration, pi over 4 and 0. And once again, we can just simplify that expression. We can just put a 4 there. Okay, so we have sine 6x over 12 with the limits of integration plus sine 2x over 4, again with the limits of integration. There we have them there. So that's the expression there. Okay, sorry, that's a little typo there. That should be 6x. So that's just the what I've typed on the I've written on the last slide, just in a bit simpler to look at. And again, this is where we have got to now. So now that all that remains to be done is to put in the limits of integration and solve. So let's just do that. So we have on one side, we'll look at this expression here first. That one there. So that's sine 6 times pi over 4. That's 6 pi over 4, or in other words, 3 pi over 2. And minus sine of 0 all over 12. And that is that side. And on this side we have sine of 2 times 4 over pi over 4. So 2 pi over 4 is pi over 2. And sine of 0 is just sine minus 0. And that's all over 4. So that works out to be, that's just a bit of calculator work, that works out to be minus 1, 0. That works out to be 1. That works out to be 0. So moving it to the next slide here. There we have there minus 1 over 12 minus 0 plus 1 quarter minus 0. And so just to sort of adding those two values together, or minus 1 over 12 plus 1 quarter, that works out to be 1/6. So our answer is 1/6.